Hi, I'm following along with Paul McWhorter's Raspberry Pi Pico W lessons. We're on number 105, and he showed us today how to use the PIO state machines to control the Neopixels, which need timing and uh, can't really be, MicroPython isn't known for being able to have precise timing like that. But anyhow, he was showing us how he did it, and um, I had already found a way of doing it that kind of um, was interesting to me. So, but one thing I thought when he was started doing this was he found this part of the data sheet for one of the NeoPixels, and I thought it was kind of funny because um, the timing that he got off this chart, they're telling you that the total timing should be 1.25 microseconds, and when you add the two up that they say for high and low, you have if for a zero code, you're going to have uh, a total of 1.15 uh, microseconds. And for the high, it's zero point 0.7 and zero point 0.6, which is 1.3 microseconds. So neither one of them end up being the 1.25 microseconds. And you got plenty of range here because they say that you got a total of zero point 0.6 microseconds or 600 nanoseconds plus or minus on that thing. Um, I've always heard that NeoPixels need precise timing, and actually they do, but you got um, pretty good range here, plus and minus on this. So you got 3.35, and you got plus or minus 0.15 on top of it. So that means this in in theory could go from zero point 0.2 all the way up to zero point 0.5, on that. And so I don't think it's the precise timing maybe that needs to be done. It's just that the computer needs to take care of each step one right after the other, and it can't go off and do something else while it's thinking about that. So that's where the PIO comes in really helpful on that. So yeah, um, I thought that that was interesting. And then, like I said, and even these numbers are out of whack. But then a little bit later on, Paul does the math on. He came up with 8 million cycles per second, and I think this is where he's at. Yeah, and if you maybe I don't know, you can't really see it up here, but when he does the math up there, um, it's zero point 0.7 over 0.125. And if you do that, we're expecting the zero point 0.7 that he's asking for, but because of the rounding, when you actually the 6 cycles, 6 times 1.25 is 7.5 or zero point 0.75 microsecond. So even the math made it a little bit out of whack on that. And that actually made me feel a little bit better because the way I found the guy started off with the presumption that he had these tolerances in his code. So by the way, yeah, Paul found this uh, what do you call it, data sheet chart, and I actually found a different. It's still the WS2812, which is the what is the NeoPixels. That's the official name for them. And if you come down here, I got a chart that looks almost exactly like Paul's. This chart here, but if you see, I got for a for a zero, I got zero point 0.4 and 0.85, and for a one, you get zero point 0.8 and 0.45, and both of those are adding up to the 1.25. So I'm not sure where Paul got his data sheet from, but and uh, kind of funny that they didn't add up to the 1.25 microseconds. So anyhow, So like I said, I can't take credit for this code because, as Paul knows, I'm a hunter gatherer, and I actually came across it, and it was so good that I said, "Nah, I got to use this because it just makes it so simple, and you don't need any conditional statements in your PIO code or anything when you're doing this." So, let's see if I can explain it as well as the thing. I'll link to this website from France that this guy showing how to use the PIO for NeoPixels his way. Oh yeah, by the way, Paul's sample, his code was quite similar to the one of the examples. This is the examples file on the PIO docs, and as you can see, some of it's quite simple, similar to what he's got. So, um, and they're using the side set and doing a lot of jumping there, conditional jumping and stuff like that. And the way this guy shows it, you don't need any of that. So let's go back to his code. So here's a representation of what the data sheet is saying. For a zero, you are using um, zero point 0.4 high and then 0.85 low. And for a one, you're using zero point 0.8 high and 0.45 low. So this guy explains here that because you got this 0.15 microsecond tolerance, that um, you can just go ahead and divide this up into three, so you have a point 0.4 middle section that could be either, and then a point 0.4 that's going to be low. So you got always are going to have a point 0.4 high, and you're always going to have a point 0.4 low at the end. And the only thing that changes is this middle, which makes it really convenient with what we have. All we have to do is use our data bit that is coming in to change what uh, this this middle section, whether it's going to be low or high. And I thought that was really good. Um, Later on, he shows it. Yeah. So instead of Paul divided his thing into 10 sections, and so this guy suggested using 5 million cycles per second, and that gives you a zero point 0.2 microseconds um, for each one, for zero point 0.2 for each cycle is going to have that. So you're going to actually divide this total thing here by six, and that'll give you 120 instead of the 125. But like I said, with the tolerances, this guy said, uh, conjectured that it would work, and it proves out that it does. So, like I said, you're gonna basically have a two cycles when it's always going to be high, and you can always set that. And then you're going to have two cycles where you're going to read what the bit is, and if the bit is high, then it's going to be high here, which is fine. And if it's low zero, the bit is zero, it's going to be low here. So that works out really well. And then for the last 2 microseconds, point two, last zero point 0.4 microseconds, it's going to be low. And like I said, this guy found out the same thing Paul did, that you can't really start out with a high or a low. You have to start here in the middle of your low section, and then you're actually starting here and you're getting, uh, like I said, it's zero point 0.4. So each cycle is a thing. So you're starting out with one cycle low, and then you're coming back around and doing the high, and then finishing off with the second half of that cycle low. So anyhow, so that's I mentioned that to Paul in the comments. Yeah, I mean, I guess this is a known thing that the program has to start here in the middle of the thing. Like I say, this guy's from French, and he said, yeah, whatever that says, it says start of the program. Yeah. So that's where you have to start it. Anyhow, so I think the next thing to do is go ahead and get to my code. Like I said, it, it's my interpretation of this guy's code. He has his code down here, and I use some of his stuff, and it's the way I do all my coding. I borrow stuff from people, but then I make it my own by doing different things in there. And like I said, this guy was using a module that I didn't know about, this array module, and it worked okay. But we're so used to using lists and everything in Python that it made a whole lot more sense for me to use the list on this. So let's get to my code. All right, so starting at the top here, the only thing we got to import is pin and sleep, of course. And then I have four things that we have. I'm creating is on my Neopixels are on pin 12, so I make that an output and give it the name pin so that I can set it down here. I'm using a 12 Neopixel ring, so number of Neopixels is 12. And here I'm setting up our pixels array. I'm calling them pixels, and I'm just setting up I wanted to get the list of lists, so I wanted to get all zeros in there in case we want to read it before we start. So, and you just to do a whole list with that number of entries in the list, you just do that times number of picks, and that'll give it to you. And I when I did this, I decided I like the way that we have brightness. Paul showed us in using the library or module library on when we did NeoPixels. It was pretty fun and pretty important to uh, dim the brightness for the cameras, and also it saves power so we don't overload our Pico with what we're using. So anyhow, this is all pretty much the same as Paul had uh, with his, and and then at the end here, we got the same thing pretty much. I'm just setting the base and uh, the set base and the out base because we're using out and set on it. Like I said, this is not my code, but I just had to use it when I saw how simple it was. So um, I'm also Paul probably had side set in there. We're not using side set at all. So like I said, we're using 5 megahertz on our clock on our frequency. So each cycle is zero point 0.2 microseconds. So we got this broken down, and I got my comments here to show that uh, we start off with we're splitting the low, and we're doing one cycle. So we're doing zero point 0.2 at 0, and then we're going to start our high. And we're doing two cycles. So that's zero point 0.4 at high all the time. It's going to be one. We're doing that for two cycles. We're doing the set, and then we're adding one to it. And then this is where the easy part of this comes in is that um, we got this one cycle here because we're pulling one bit in um, uh, from our OSR to X. So we're pulling in just one bit, and um, we're putting that in X. So, and then if that's a one, then X is going to go to the pin. So this is going to be one. So like I said, you got two cycles high, and then this two cycles is either going to be high or low depending on what the X is. And then you're going to end up with one more cycle low. And then when it goes back, you're going to get your other cycle. So your other zero point 0.2 milliseconds up there. I just think that this is this guy come up with this, and I just found it so elegant that I can't see using the side sets and all that. It just makes more sense to me the way this is done. Anyhow, and it works really well, so can't say anything. So then Paul's told us that we had to make something pretty with our NeoPixels. So First thing I had to do is, if you're using the library, I forget what they use. I know that on Arduino it was pixels.show or something like that. And so I just made my one to update the Neopixels to work with the PIO. I just called it show. So anytime you want to update the pixels, I just call show. And this is where I'm incorporating our brightness into it because our brightness is 0 to 255, but when we're pulling out so I'm going over all the pixels and we're bringing out the 0, 1, and 2 elements of the inside list, and we're multiplying it by brightness, and we're taking the into that. So we're getting our red, green, and blue. And then Paul was showing that we do this G shift 16 or it doing a logical or with it, and then uh, the R gets shifted 8, and then the B just gets in there, and they're ORed together. And I noticed that this guy up here, like I say, I just borrowed this line of code from him, that this works as well, that you can do this plus this because they're not going to overlap because you're shifting them. So this is only going to be, bits 17 to 24, and this is only going to be um no, I guess, yeah, whatever they are. This is uh shifting the bits anyhow. So we got that, and then we're just doing the same thing that Paul showed us, that we're doing 8 bits at a time, and we're just sending them in there. So seems to work well, that does. And like I say, I only call this when I want to update the NeoPixels. And like I said, that, that has nothing to do with up. At this point, you're not changing the array. You're just reading the pixels list of lists that you have. So some of the other things I have to do now, that if you want to like fill your pixels with a certain color, all of them the same color. I have this one, and all this, like I said, this takes care of feeding the PIO, and everything else that all these other functions I have to do with making it look pretty and filling the pixels with different ways of filling the pixels with color. So for this one, like I say, we're putting all the pixels at the same color. And uh, so we're just doing for X and range of pixels, and we're making that pixel array to whatever color that we're importing. So we're doing that. And I also put a second argument in here to whether you want to update it or not. So when you fill it with color, sometimes you fill it with color and then you just want to start manipulating some of the other pixels. You don't want it to show on your pixel right away. So my update is default is false, but you can put that second argument as true, and it will update at the same time. So I have this if update is true, do the show, and it'll uh, update your pixels. So you'll see throughout here, sometimes I have the pixels the fill color is false, and sometimes I don't. I mean, it's true, and sometimes I don't. So, and the cool thing is you really don't have to remember what this update is if you don't want to, because this one has got to be here. And so you can just put a color, a tuple or a list of 3 colors, and then you can put comma and put true, and it knows that that's the next one in line, and it's going to just do it. So you can do that. So let's go down and we can show that working, I guess. So I just have these are all definitions down to here, and this is actually starting where I'm going to just start using what we got. So like I said, I got the fill and I got a list here, red. So it's red, so it's 25500, and I have it true so that it'll automatically update that. So let's go ahead and run this and we can show it. All right. It's kind of bright on the thing, but you can see the Neopixel ring is all red on that. So if we want to change that to 0, make it blue, 255. We can run it again. And like I said, I didn't turn it off. It just left it on. So now I'm gonna turn it and it turned to blue. So that works fine. So we can do that. So now we'll go to this wipe thing. So let's go up and look at what the wipe function does. So wipe function basically takes one at a time and fills the pixels one at a time and then updates it every time. So it's going to be a certain color and this is the dwell time. This is how long in between each pixel comes on. So I have could be, um, if you don't put this in, you can just put a color. And if you don't put either of these in, then it's going to use whatever the defaults are here. And then normally it would be clockwise. It would fill in a clockwise, well, clockwise for you guys. Um, it would fill in a clockwise direction. So I just realized that my camera is reversed. So everything anything that's clockwise is going to be counterclockwise when I got that. So anyhow, you'll just have to take my word for it that when you're looking at it, it's clockwise. So, so all you're doing, like I say, we're for eye and range a number of pixels. If it's counterclockwise, well, let's do clockwise first. This is if it's not if clockwise counterclockwise is false, that means it's clockwise, and we're just taking each pixel and we're um, setting the color, and then we're showing it, and then we're sleeping for a certain amount of time, our dwell time, and then we're going up and grabbing the next one. Now, if we're going counterclockwise, you got to do a little bit of math inside of here. So it's the number of pixels. So if you got 12 pixels, your top pixel is only number 11. So, I mean, yeah, so it's 0 to 11. So 12 minus 1 is 11, and then minus whatever I is. So I is going to go from 0 to 11. So that's how we get counterclockwise on there. So let me go down and see what we got. So we had a wipe, and it's a red wipe, I think. Yeah. So I got both of them there. So it's going to fill it, and then it's going to do the red wipe. All right. Let's do that again. It's going to turn it blue. This is going to fill it all with blue, and then it's going to wipe it. Blue, and then wipe it red. There we go. So I got I'm working on making it pretty for Paul. So these are all about the same. I'll just show you that we're sleeping a little bit in between. And this one I changed the speed, and I also made it counterclockwise. And so we'll do that. So it's going to start out blue, and then it's going to do whatever it says it's going to do. So and you can see the different directions. Like I say, the camera looks like it's backwards when you're doing it. Blue. So that was red, white, and blue. So that's cool. We can run it again. Red, white, and blue. Cool. So we're trying to make it pretty. All right. So back out that one. So then I have this thing called follow. And let's go up to follow. So we have a follow here, and it's taking uh couple arguments, but one of them is default, and that's the number of loops that it's going to do when it goes around. So it has to have a color come in. And the first thing we're going to do with this one, because most of the time you don't want to do it when you're doing the wipes, a lot of times you don't want to clear what's on there when you start. But for the uh, for the follow, I thought it was important to clear it first. You could leave that out if you wanted to. But basically, we're doing for eye and range number of picks times loops. So I got 12 pixels times 3. So this will be 36. And I'm using the modulo operator here so that it stays in range, that it's going to take the remainder of what it is. So that's good. And so whatever your eye is, it's going to stay good. And we're going to put our color. And then what we're doing is we want to turn off the color that is um, 3 steps behind it. So that basically you have 3 pixels showing as it runs around it. And it's kind of, like I say, follow the leader's time style. So we're just turning it off when we do that. And like I said, we're showing it and then we're doing the dwell. For the follow, I didn't put dwell up there, but we're going to just put 0.1. And then at the end, we're just going to make it all black again. So like I say, I added this, so each time it's going to take a little bit longer to get going. So you can see we're filling and then we're wiping 3 different colors, and then I'm going to do the follow with looks like I'm following with green. Yeah, there we go. Red, white, and blue. That's how we're following. So it's kind of like chasing around. I think Neopixel's called that chase. So then I have one just because I want to be patriotic today is we have a follow that's red, white, and blue. So um, basically you don't pick what colors it is. It's going to be a 1 pixel red, 1 pixel white, and 1 pixel blue. And it's basically going to do the same thing, except you're going to set each pixel here what color you want it each time through. So we'll show that running. Follow red, white, and blue. There we go. So blue, then red, white, and blue. And we're going to chase with green. And then we're chasing red, white, and blue. You probably can't tell that's red, white, and blue, but it is. All right. So the only thing else I got to do is the rainbow cycle. And I'm not really going to try to explain this. The rainbow cycle is something that I uh, ported over from Arduino. I know Paul uses a different way of doing it, and I just like the way that that we use what they call the wheel to get 256 uh, colors in the color wheel instead of, I think Paul does 360, like for one for every degree or something like that. And they work basically the same, but this was able, I ported this straight over from Arduino and it worked. And the same way with the rainbow color, that you can make it work like, just like that and everything. And um, again, you're just putting this in here and uh, code's right there. At one point I knew how all these numbers did, but at this point I'm not going to explain it. I'm just going to show you the pretty colors at the end. So this video's got really long, so anyhow. So let's go. Red, white, and blue. And green is going to do 5 loops. And red, white, and blue is doing some loops. And now, oh, I didn't set that on. I must not have turned it on. I didn't. There we go. Let's try this again. We got to go through it all again. All right. Starting off blue, then red, white, and blue. And then we got green cycling. And then red, white, and blue cycling. Now we should get the rainbow going around in a circle. Yeah, really can't see that. That webcam really is washed out. And like I say, I only have the brightness on 0.1, so that's kind of a mess. I know this video got lot longer than I did wanted it to, but uh, I really thank Paul for bringing the PIO and teaching us how to do it. And like I say, I jumped on the web and a while back and found other ways of doing it, and that's the beauty of programming for me is just taking everybody's different uh, ideas and mashing them together myself and coming up with something that I can call my own almost. I really can't call this my own. I copied that from that guy, but like you say, I incorporate other stuff into it to make my own, but this I can't say how many times this is elegant. 4 lines of code to do Neopixels is just that just amazes me. Anyhow, all right. Talk to you later. Thanks for watching. Have a great day, everybody.